Bonjour à toutes et tous et bienvenue dans Z Science. Nous sommes à l'université de Namur, plus particulièrement au Namur Research Institute for Life Sciences et nous allons parler de biologie cellulaire. Nous allons le faire en compagnie de Alison Forrester, une chercheuse qualifiée FNRS ici à l'UNamur.
Alison Forrester est chercheuse qualifiée FNRS. Elle a beaucoup voyagé avant de poser ses valises à Namur. Chercheuse en biologie cellulaire, elle s'intéresse au processus de sécrétion des protéines, un élément clé de nos fonctions cellulaires et donc du fonctionnement de notre corps.
Hello, Alison Forrester. Thank you for welcoming us in your lab, or one of your labs.
Yes, absolutely. This is our main lab here for my group. And so here we do the majority of our standard protocols like immunofluorescence, as you can see here. But then actually this space is shared by the unit. There's 4 other groups here. And we have other rooms that specifically are for different experiments like cell culture. We also have microscopy, which is a very nice big area dedicated to that.
And what kind of materials and technologies do you use most in your lab?
So we're most interested in microscopy. So we use advanced microscopy to localize the proteins within cells. And actually here we've been really lucky in the past few years at Namur because we've received a huge investment from funds such as FNRS to really invest in new advanced microscopes. So actually one of the main types of microscopy that we use is confocal microscopy, and so this is where you can take very fine sections, slices throughout a cell, and you can see very clearly where a protein localizes within the cell or if it co-localizes with another protein. We have another really exciting microscope that does super resolution microscopy, and this is actually based on the technology that won the Nobel Prize in 2014, and this actually allows you to see proteins so close together that it's actually beyond the resolution of light, so that's a really exciting tool that we have here. And then another incredible one that we have just acquired over the last few months is called the lattice light sheet microscope, and this is a really cutting-edge microscope and it's the first in Belgium.
So Alison, you're a cell biologist, you work on proteins. Why are proteins so important for our cells and our body?
So actually the body is made up primarily of proteins and then also of lipids and of waters. So proteins are responsible for all of the processes that happen in the cell. They're responsible for communication between cells, for digestion. They give tensile strength, for example, in bones, hair growth. So really they're an essential part of the body. So because they're so essential and widespread throughout the body, their synthesis is very, very complex and very important. So they're produced in one area of the cell, and actually you can very much visualize protein synthesis as a kind of car production factory.
Really?
So yeah, so the proteins are made in one area of the cell, and then they're modified as they travel throughout the cell, and then just before they're distributed, they're assembled finally. So for the proteins, it's the same, and so they start assembly within the endoplasmic reticulum, which is my organelle of focus, and then they're packaged into transport carriers at the ER exit sites, which is literally the site that proteins exit from the ER, and then they go to the Golgi where they're modified, and then they're distributed either throughout the cell or they're secreted.
And could you explain what's the specific role of your research?
Yeah, absolutely. So in my last postdoc position at the Institut Curie in Paris, we actually discovered a compound that could inhibit the protein trafficking of a specific protein. And so this was a proof of concept that we could actually inhibit the ER exit of proteins. So now I'm taking this forward to study what effect this has on the cell, which proteins this can affect, and also to study whether this correlates with a disease that we could use to treat it. And my group also, we're going to try and identify more compounds that can target different areas or the same area of the protein secretion pathway, and thus target different proteins and thus try and treat different diseases finally.
When we were preparing this interview, you said that collaboration is the key of success. What does it mean for you exactly?
Actually, I really like to work with chemists and physicists and also computational biologists, because I think that these people really help you to look at your project in a very open and different way. And so, for example, a question that a physicist might think is really simple seems to me like science fiction.
Okay.
And likewise, if I look at a process that I just accept to be true, a chemist might actually really question why this is the case, and by doing this, you re-look at the things, you re-evaluate the things that you think you know. And so really having this input and really taking apart all of these different processes in this way, it really helps you to build a more creative project, and you can really think outside the box. And you just can't do this on your own.
Thank you very much. Thank you.
Thank
you. Bye-bye. Voilà, fin de cette émission. Merci de nous avoir suivis. Pour ma part, je vous retrouve avec grand plaisir pour un prochain numéro de Z Science.